Hello everyone, my name is Ragini, Assistant Professor from Department of ECE, Kamaraj College of Engineering and Technology, and today's presentation topic is Class B Amplifiers operation. So in this, Class B amplifier is a type of a power amplifier, we all know that, and in which the active device, that is a transistor, conducts for one of the half cycle for one input cycle, that is 180 degree of conduction angle, and the quotient point is located on the x axis itself. So depending upon these types of two transistors, whether PNP or NPN, the two circuit configurations of Class B amplifiers are existing, and that are push pull Class B amplifier and complementary symmetry Class B amplifier. So the operating principle, to get the full cycle across the load, so the pair of the transistor is used in a Class B amplifier. Here the one transistor handles the positive half cycle and the other handles the negative half cycle. So this reduces power dissipation and increases the efficiency. This is the significance of Class B amplifier. And coming to this operation on detail, the push-pull Class B amplifier, whereas for the positive half cycle, Q1 alone are able to transit, and for the negative half cycle, Q2 will able to transmit the cycle. And the characteristics and the efficiency is about the range of 78.5%, which is much higher than Class A amplifier, which gives the efficiency of 25 to 30%, and the power dissipation is lower because transistors are off for a specific half cycle conditions. And here the distortion characteristics shows the crossover distortion occurs at zero crossing of the input signal. So this happens because both the transistor remains off near zero voltage, causing a distortion in small signals, and it can be used and it can be reduced using Class AB biasing by slightly turning on the transistors. The voltage gain and output power. Class B's voltage gain depends on the circuit configuration, whether it is a push-pull or transformer coupled Class B amplifier, and power output is high, making it suitable for audio power amplification. And input output impedance, here the input impedance depends on the driver stage, and the output impedance is low, making it good for driving the low impedance loads like speakers. Then the circuit diagram, here the typical Class B, the circuit diagram. In the circuit diagram, the Class B push-pull amplifier consists of two transistors, one NPN and one PNP, and the center tapped transformer optional for impedance matching circuits, and biasing resistors to maintain the transistors at cutoff region when it is ideal. And the transformer coupled push-pull circuit is shown here, whereas where the voltage is given in the input. This is the input part of the particular circuit, push-pull Class B circuit, and this is the output part of the push-pull circuit, whereas in the input circuit we have a driver transformer and it is a center tap, and where we have two transistor, one is Q1 and another one is Q2, and in the output transformers we will have another output part of the circuit, we will have another output circuit with the load connected, whereas in the driver transistor it operates for one particular circuit, one particular cycle, which is a Q1 cycle, where it gives one positive cycle, and in another half it gives a negative cycle where the Q1 is off state and Q2 is in the on state, and the corresponding waveform is obtained. And the push-pull Class B amplifiers operation, here the push-pull circuit requires two transformers, one is a driver transformer and another one is output transformer. Both transformers are center tapped transformers. In circuit, Q1 and Q2 transistors are of NPN type, and it also uses a Q2 for PNP type. And push-pull Class B amplifiers operations, the driver transformer operates the circuit, the input signal is applied to the primary of the driver transformer, the center tap of the secondary of the driver transformer is grounded, and center tap on the primary of the output transformer is connected to the supply VCC. So the entire push-pull Class B amplifier operation is stated here. So during the positive cycle of the input signal, the voltage on the secondary side of the transformer is either the positive on one half of the cycle, which is related to the center tap, and the negative on the other half relative to the center tap, and this causes the voltage in two halves of the secondary winding to be equal in magnitude but opposite in polarity. As a result, the input signals applied to the transistors Q1 and Q2 are 180 degree out of phase. This is the significance of the Class B push-pull amplifier, and this pushes Class B configuration ensures Q1 turns on during the positive half cycle, where Q2 remains off, and Q2 is on during the negative half cycle, while Q1 remains off. So, this allows efficient amplification and also reduces the power loss. And this is the operation of positive half cycle of the input, and the operation of the circuit holds the positive cycle of the input and A is positive and B is negative. Due to this, Q1 gets driven into active region while Q2 is cut off, and thus that is the current flows, while IBT will be current in the transistor second transistor will be of 0. Hence, the current flow in the circuit transistor 1 flows through upper part of the primary of the output transformer, while the current will be on the 0 on the other side. And this is the operation of the negative cycle, and which also implies the positive cycle operations. And this here due for the negative half cycle of the input, B is positive and A is negative, and due to this Q2 gets driven into the active region while Q1 is cut off, and for the current B2 will be 0, which whereas the IM will be 0, and hence I2 flows through the lower part of the primary of the output transformer, while I1 current will be 0. And these are the waveforms of the push-pull Class B amplifier. And advantages: higher efficiency than Class A amplifier, which is around 78.5%, and less power dissipation when no input signal is present, and suitable for high power amplifications like audio amplifiers, as I said earlier. And disadvantages: crossover distortions at low signal levels, and requires precise transistor matching for good performance, and requires a split power supply for both positive and negative voltage rails. And this is my overall presentation about Class B amplifier. Thank you.